Hello everyone, welcome to this video Docker for Beginners step-by-step guide. So in this video we are going to get an overview about containers, concepts, and how to install Docker, uninstall, and many other things. So the first, I will list all the commands that I will use in the demo, so it will be very easy for you if you want to copy and paste or if you want to remember the command, so you can. And I will post them as a part of the description in the video. The second is we are going to see the difference between virtual machine containers and Hyper-V container, which used by Microsoft in Windows platform. Then we will start understanding what is the Docker and the value preposition of VM vs containers. Then we will understand the difference between images and containers. After that, we are going to talk about container deployment workflow, which is very important to understand all the complete life cycle, creating the image, storing the image, pulling and push the image, how to make a snapshot of the container, and many others. Then we will introduce the Dockerfile, which is the way that we work with Docker in a silent mode using Docker build. After that, we will go to see the bridge networking and port mapping, how to expose port from the container on the hosted machine or the hosted node. And after that, we are going to cover the container and CI/CD or continuous integration, continuous deployment or delivery pipeline, and what is the relation between them and how this fit inside the DevOps. And we're going to the demo where we will see from the beginning how to install Docker, how to uninstall, and then how to update the packages, edit the package source file, and running container, download image or pulling image, and many other different commands with Docker. So first, let me give you a quick introduction and background about myself. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps. So I have been doing software development for more than 15 years now. I worked with many projects, helped many customers, heavily participated in the community, worked in many countries for different projects. The more questions you ask, the more we all learn. So I will encourage you, don't hesitate. If you have a comment or question, please leave it in the comment of the video, because this will raise a discussion which will bring more values for everyone. So this is the commands that I will use in the demo. So it's very easy that you can use them. And again, I will put them in the description of the video to be very easy. To understand what is a container, let's see the difference between containers and virtual machine and Hyper-V container. Virtual machine created and managed by hypervisor, such as VirtualBox, Hyper-V, or even VMware. And this machine running on a host operating system, which could be the same, but it requires a complete, a separate operating system. The main reason behind that, this will give a high level degree of isolation, but on the other side, the cost for that is longer time to start up, not effective portability. For example, if we want to move a virtual machine, just imagine one virtual machine could maybe has like 120 gigabytes and move them over the network or between PCs. It's not very effective. High memory requirements as well. But when we look to containers, we will find that containers leverage the operating system that is already in place to offer much separation. So, for example, RAM requirements are lower. The operating system is not duplicated because it uses the same kernel of the hosting operating system. The size is less, so moving over the network or between PCs become much more easier, and the cost also become easier because in one virtual machine, for example, when I pay on the cloud for virtual machine, I can create many containers on one virtual machine. On the other hand, Microsoft has created what they called Hyper-V container, which is something very similar to the container, but it has its own operating system. So this is the main idea here. The operating system optimized for containers. So you can think it's something between container and virtual machine. This is out of scope. We are not going to cover that, but just to give you the idea about what is existing now. So what is Docker? Docker is a leading open source containerization platform. It is containerization technology, and as we saw in the previous, the Docker is working as a containerization engine in the layer above the operating system, which gives the utilities and the tools to create, manage, run containers. Value preposition for VM vs container. When we look at the value preposition for each of them, we will find that in the VM it has a separate OS, which is again give a high level of isolation, which is not provided by the container, by the way, because for example, I can create two containers with two operating systems, because they're using the shared kernel on the host operating system. On the VM, we will find that it has larger size compared to container, here a small size, which again, because the container leverage the hosting operating system, and this is one of the main feature that gives a container the ability to be fast, quickly, and very easy to move over the network and all of that. Minutes to create and provision, no need to create or provision, minutes to start to stop, seconds if it's not very quickly, I will say even fraction of seconds to start, and fewer can be created on physical machine, while many container can be created on virtual or physical machine. So what is the difference between images and containers? The best example to understand that, to remember the class and the object. Images is the instructions of the container, and once I run the image, I will have the container. So the container is the executable. This will be in the memory, but the image is just static. So the same as a class and the object. So from one image, I can create multiple containers. We will see and understand more in the demo. Container deployment workflow. This is the most important slide in this presentation. It starts by we have a Docker registry, which is a public container that it has many images. And this could, of course, be public or private, but it's usually on the internet. And example of that, Docker Hub. So I start by pulling an image from the Docker registry. So I just get an image. Now I have the image on my computer. Which is again just a file system that exists on my computer. And of course, on my computer, Docker is installed, the Docker engine. Then I start using Docker to run this image. Then I will have a container running inside the Docker instance or Docker engine. So I start working with that, so I can stop this container. The same concept as the virtual machine, I mean, for start, stop, restart. Also, I can start adding or changing in this container. So for example, I can create files, I can create directory, copy file, and this is usually, it will be, I will start install a web server on the container, then copy my web application to the web server, and so on. So let's think that we start by installing a web server on the container. Once I did that, I start committing the change so I can have a new image. And it's very important to commit, because if I forget to commit, then I will lose a change. So if I stop the container and start again, I will lose any changes if I didn't commit the change. So once I commit the changes, I have a new layer. And so this will not be on the same image. It will be another image, and only with the delta between the original image and the new changes. And this is the beauty of Docker containers, because this makes the difference is very few or very small, which can be very quickly transferred over the network and the internet. And at the same time, I tag this change so I can distinguish this image from other images. Once I tag that, I start pushing to the Docker registry so I can save it, so I can get this later. So now I have it, and this is the life cycle once I want to add more changes to the container. Just adding one layer, commit that changes with a tag and push to the registry. Add another layer or a change and tag, and so on. When we're talking about Dockerfile, Dockerfile is the way that I present all my instruction inside a file. So I can work with Docker in two modes. The interactive mode, which is from the command line, or the silent mode, where I put all my instructions inside a Docker file, which will be used Docker build to build this image. Also, I can use save with backup tar, so I can make like a snapshot of the image at any time, and I can load that if I want to, making like snapshot and load this snapshot while I'm working on the image. Of course, this is during the container, from the container. Let's look at the Docker file. As we can see, this is the Docker file, the instruction how we build a Docker image. It looks very similar to the native command, so it will not make any difficult for you. So if you understand the interactive mode well, then you can very easily type the Dockerfile command. Each Dockerfile command create a new layer. So once you put it, it executed separately as a one layer. Docker Bridge Network. It's very important to understand how we expose and make a bridge network and port mapping. So by default, when the port is exposed, this port will be exposed within the hosting machine. For example, if I have a container and I open port 80, for example, this port 80 will not be exposed to the public unless I making a bridge between this port and other port. In the demo, I will show you how to deploy a web server and expose this port and making this bridge. Now let's talk about containers, CI, CD, or continuous integration, continuous delivery, and DevOps. This usually starts by you start developing and then having a Docker image, and then you push this Docker image to Azure Container Registry or any Docker registry. Once you have that, then you start pull the image from the registry and then deploying that, for example, in Azure Kubernetes services. This is just for example. And this part is covered by the CI. So we usually deploying or push the image using the continuous integration pipeline. You are not going to push the virtual machine from the command line or from your IDE, but instead we will using the CI or continuous integration pipeline to create the image and push the image to the registry. On the other side, pick the image from the registry and start deploying that. Also, this will be the continuous deployment pipeline. And usually, of course, we are not going to deploy that directly to the production. We will have different environment, like, for example, testing environment, user acceptance testing, pre-production, and then promoting the image from one environment to another. So the main idea here is to understand where the CI and CD with DevOps fit with containers, is to understand that the life cycle about pulling and pushing image between registry and developer machines and the deployment or the environment will be usually by continuous integration and continuous delivery pipelines. And of course, this, for example, if this is a microservices, this will be exposed with the application and people can access that. So all the commands that I will use in the demo, it will be here, and I will leave them in the description of the video so you can take copy and paste very easily so you can practice on the demo. I will start the demo by going to my Azure portal, or you can go for any cloud provider. The first step is to create a virtual machine so I can work with it in the demo. So here I will select the virtual machine in Azure and click Add. And I will choose from the marketplace, so I can choose the template for the virtual machine and search for Ubuntu. And here Ubuntu server. At this moment of creating the video, Ubuntu server 18 is not fully supported for Docker. This is why I'm going to use version 16. So I will select version 16 and create. This will bring me the creation. Here I will choose a new resource group. Will be the container for my resources. Linux, the name of the virtual machine. I choose password, and here I will type my name or my username and the password. It's very important to open port 22, which I will use to the SSH remote connection to the Linux machine. This will validate the parameters of the template, and now it's going to create the virtual machine. So now the machine is created, so let's go to the virtual machine and try to connect. Now I will copy that, the SSH. Here is the IP address of the virtual machine, and this is the public IP, of course. I can take the IP and using PuTTY. PuTTY is an open source terminal or telnet that I can use to connect terminally to a Linux machine. I installed PuTTY already, and I just paste the IP here, and here is port 22, so I can connect. Or I can use git bash. I prefer to use git bash, but I just give different options, so let's use git bash. So I will paste here the SSH username, and here to confirm, yes, and type the password. Now I am connecting, and if I type sudo, it will show me the switches, which means that everything is complete. I will start by command docker to see what will happen if I type docker. This will show me that docker is not installed. They don't understand docker. Even they give me some tips. It tells me that I can use sudo apt install docker. So let's using that without sudo. Install docker.io. So when I try that, we will find that because I didn't use sudo, so I don't have the enough permission to install that. So first, let's talk about 2 points here. The first point is sudo, which is mean super user do, and this is the root user, and this to get the permission needed to run with the root user. So I need to put sudo with every command. This is for people that are not familiar with Linux environment. The second point is using apt. So what is apt? apt is a package management for Linux. So what is the meaning of the package management? Package management, it's just a public repository that has different application, and then I can just using a command line, I can download and install the package. For example, operating system, we have apt for Ubuntu and Linux. When we're using Red Hat, Fedora, we will using Yum, and when we're using Windows, we will using Chocolatey. And for software development, we have different package management as well, the same concept, like NuGet for .NET development, NPM for Node package management for JavaScript development, and many others as well. Let's get back to sudo. So for permission, it's either I go for the root, and in this way, I don't need to write sudo with each command, but this is not recommended because I could accidentally remove or create any problems, and it's better to run sudo with each command. So by typing sudo bash, enter, now I am in the root user, and I don't need to type sudo anymore with any command, but this is not recommended as I explained. So it's better to exit from the root user and instead using sudo with each command. I still need another thing to be able to install Docker. I need to update the package management, and this updates because if I try to install Docker now, it will not be installed successfully. The main idea here is to update the package management software, or it could be update the package management source, which will be where is the public repositories that this package management software using to search for the software. To give you that example, so you can, if I type sudo nano, this is for editing, and open the package management source list, which is list all the sources here, where is the sources, so I can add manually or run the update which will updating the source or updating the package management version software. So I will run the package management update, sudo apt update. So this will update the package management. It's either the software or the source. Then I will type sudo apt install docker.io. Confirm, and then the Docker will be installed. So this is the correct steps to install Docker on Ubuntu 16. So now Docker is installed. If I type now sudo docker, then we can see all the switches. It's very easy to remove or uninstall Docker. And to show you that, all what I just need to type sudo apt remove docker.io. Confirm, and then this will remove Docker. So now we understand how we install and uninstall Docker and all the prerequisites. Let's now install again. Now it's completed. The first step is to list all the images that exist on the current machine, all the Docker images. So I will type sudo docker images. This will give me the list. It's not very clear. Let's clear the screen. Type again, images. So we can see we don't have any images on the current machine. So what we will do, we will just go for Docker Hub, which is a public repository, but this repository for the images, not for the software this time. So Docker Hub is a registry, and searching for, we can see here different images. So if we go for Nginx, for example, this is an example, and we can see this is a command. So if I type sudo docker pool and the name of the images, which is Nginx, then this will, as we can see, it's pulling that image from the Docker Hub or Docker registry. Let's see the images now on the machine. Sudo docker images. We can see now we have one image. In the same way, I can just pull the images that I would like to work with. So just to get back to the images, search for the image that I like to pull, and then with the same way to pull it. So now let's try to see the running container by typing sudo docker ps process. So we can see now we don't have any running container, and this is very good example to understand the difference between image and container. So we have one image, but we don't have a container, because as we explained, the image is like a class and the container like an object. So I can have running multiple container from the same image. So let's run a container from our Nginx image. Clear the screen first. Sudo docker run Nginx. So now I run the container. I am now inside the container. So let's open another git bash and connect, so we can see this container from outside, from the machine. So if I get back here and then copy this again, type the password. So now I connect sudo docker ps. So now we can see that I have one running container. So let's open another git bash to run another container. Let's connect first. Type the password. Sudo docker run Nginx. So now I am inside the second container, and if I run process again, we can see that I have two containers running. And if we look, we can see even the time created, the status. For example, this the second container, this is the first container, and I can see the container ID if I want to stop. So let's see the process in more details. If I type sudo ps3, which is a utility in Linux, then we can see that the Docker container running a two different process for each container, which is a two containers. This is in details. Let's clear that. Let's stop a container, but let's list the process first, the container, and I will copy the container ID. Let's copy that one so we can stop this container ID. Now sudo docker stop and paste this container ID. Now I stop that. So if I want to list again the running container, we can see that I only have now one container. And if we get back to this, we can see that we get out of the container because it is forcibly stopped, but we're still here inside the container. If I type sudo docker, we have many switches as we can see. So for example, if we go for the commit, we can see the description, create a new image from a container. Because remember, if you have any changes on the container and you don't commit a new image or commit these changes, it will not be saved. So if you stop the container and run the container again, it will lose all the changes. So I have to commit and create an image in order to save this. Of course, I can use a snapshot, but this is another point. So we have the commit. We have also like a copy to copy files to the container. We can have pause, so I can pause the container. I pull, which we're using, push to push the images, restart. So we have different commands and utilities that we can use with Docker, which is, as you can see, it's very easy. Let's move to how we can have a container that's running a web application, a very small web application, and also how we can expose a port so we can access this web application. So let's first go for our machine and open the port 8080, because this will be the public port that will be open to the public. And then from here, I will type sudo docker pull. This is a new image which has a web application with a hello world HTML page. So I will pull this image. Let's see the images now. Sudo docker images. As you can see, I have two images now. So let's run the hello world. So now I'm inside the container of the hello world. Let's open another git bash to connect. So we can see the container from outside. This is the password, clear, sudo docker ps. So we can see that the container now, and we can see that the port 80, because this is this image has a web server and it opens port 80. But this port opened internally for the machine, but for the public port, it's 8080. So if I try to access 80, it will not give me the option. But since I have this rule now on the network is that I expose 8080, this will route me to my port and the web application. Let's see that. If I took the IP of the machine, and write 80, so this will not load because we didn't map 8080 to 80 port. So what we need now is to running the container and routing this port inside the container, the configuration of the routing. And this is exactly what I'm going to show you. So what we need now is, first I will exit the container by Control-C, clear, and then running the container. So if we run now, we can see that the container stopped. And then running the container, but in this time, I will routing the port 8080 to be 80. So this is routing rule for the container. So now the container is listening. And as you can see, it's automatically routing in the background. And we can see here that the port is pointing to the rule, and in the background we can see that the web page is loading, as we can see. So this is a hello world from a web application with HTML inside a container, running inside a container. So let's have another experience with the Windows, and to just give you that it is almost the same experience. So I will create a Windows 10 machine and then installing Docker. The machine here, I will call it Windows. Here the username, password. The main idea is to just show you that we almost have the same experience working with Docker on the Windows platform. We'll choose the size of the virtual machine. And create the virtual machine. Now the machine is completed. I can connect to the machine with RDP, remote desktop connection. Then I will type the username and the password of the machine. I'm connecting. And once I have that, I will just install Docker for Windows. I will copy this URL, go to my virtual machine, and access this so I can download the software from here. I will take the stable. We can take the stable or the edge channel, which means the last version, which is sometimes is not very stable. So I took the stable version and start installing that. So this will install Docker for Windows. I will choose to use Linux so we can have the same experience. Then close, log out. Now I sign out from the machine. It will restart. Once I complete the restart, and we can see that the Docker is going to start. I'm waiting a little bit until the Docker start and the engine is running. Yes, I will enable Hyper-V container feature. This will require also to restart, and this is after restart. Now we can see this green light, which means that it's running successfully. And if we open the command line and just start typing the same command, docker start by Docker version, so we can get the version. Docker images, the same. We don't have any images. And let's pull the Nginx from the Docker hub. We can see that now we have pulled the Nginx image. It's completed. Let's clean the screen. Docker images. We have two images. And if I run now Docker run Nginx, it will run the container, and now I'm inside the container. Let's open another instance. And if we type now Docker PS, now we can see that we have one running container. So as we can see, it is the same experience, almost the same experience with Docker on Linux. At the end, I would like to thank you for watching the video. Please, if you have any question, don't hesitate to ask and reach me. And you can click and reach me on the link that will appear on the end of the video with other links for other videos, which could be useful for you. Thank you.